0, notice that the answer here would be 0 minus 0 plus 3. So at t equals 0, Blinky would be at 3 on the number line. So that's how this would be used. Okay. So simply we can be given questions like, where is Blinky at t equals 2? Or where is the particle at t equals 2? Well, kind of like I just did, this is just a matter of substituting 2 into the position function to figure out where it is. So in this, to answer this question, we just want to find s of 2. So when you plug in 2, it's going to be 2 squared minus 4 times 2 plus 3. So that's going to be 4 minus 8 plus 3, so we get negative 1. So Blinky's going to be at negative 1 on the number line, negative 1 meter from the origin, okay, at t equals 2. Okay, so that's the first kind of question. Second kind of question. What is the particle's displacement during first 2 seconds? Now remember that displacement means where do you end up relative to where you start. So to answer this question, it's not just a matter of plugging 2 into the position function. That's where Blinky is at 2. But we have to answer the question, where is he relative to where he started? Now remember, when I started this, I said that at t equals 0, which we'll assume is the starting point, he is at 3. So if he ends up at negative 1 when he was at 3 initially, where is that relative to where he started? Okay, so basically what we want to do here is, as I noted earlier, you have to find the initial position, which you substitute 3 into the function. And we just found in the last problem, s of 2 is negative 1. So what we want to do is we want to subtract those values. Okay? This is where we are initially, this is where we end up, and those are obviously 4 units apart. Not only are they 4 units apart, but you also have to think about it directionally. Is it 4 units to the left of where we started, or 4 units to the right of where we started? Well, we started at positive 3, we ended up at negative 1. So that means the displacement, we would say, would be negative 4 meters. Okay, because we ended up left of where we started. Okay, so that's how you think about that kind of question. Now, you could also be asked to find velocity and acceleration. Let's say we're asked to find the velocity function. Well, again, that's just a matter of taking the position function and differentiating it. So using the power rule, derivative of t squared is 2t, derivative of 4t is 4, derivative of 3 is 0. So the velocity function is going to be 2t minus 4. The acceleration function is going to be the derivative of velocity, the rate of change of velocity. So if I take the derivative of this, it's just going to be, derivative of this is 2, derivative of 4 is 0, so acceleration is going to be 2. Okay. Now the units of velocity in this particular problem, s was in meters and t is in seconds. So velocity is going to be meters per second. Okay, so let's note that. And then acceleration is going to be units of velocity, meters per second, okay, or meters per second squared. Okay, and then say we're asked to find the acceleration. And direction at t equals 4. Okay, well, to find its acceleration at t equals 4, that's just a matter of finding a of 4. if you plug 4 into the acceleration, notice that you always get a constant because the acceleration is constant. So a of 4 is 2. And since acceleration is positive, acceleration is signed just like velocity is. So if we have positive velocity in this context, that means that the particle is moving to the right. Negative velocity would mean the particle is moving to the left. If we have a positive acceleration, that means the particle is accelerating to the right. And if it's a negative answer, then it would be accelerating to the left. That's the way you think about it, directionally. So it's 2 meters per second, meters per second squared. Okay? But it's accelerating to the right. And that's how we would say that. So that's the acceleration and the direction of acceleration. Now, if we actually wanted to find just what direction is it going at t equals 4, I would find velocity at 4. So to find velocity at 4, I plug 4 into this function. It'd be 2 times 4 minus 4, which is 8 minus 4, which is 4 meters per second. And since the velocity is positive, that means the object is moving in the direction to the right. Okay? So it's moving to the right and it's accelerating to the right. Okay? So one thing that's a really important thing to remember here is to answer the question, is the particle speeding up or slowing down? Well, in order to answer the question about whether it's speeding up or slowing down, you actually have to compare the acceleration and velocities. And the rule is that if acceleration and velocity are in the same direction, then the object is going to be speeding up. And if they're in opposite directions, so if you're moving this way but accelerating this way, that's actually going to be slowing you down because those forces are moving in the opposite directions. Okay, so in this particular case, we would say the object is speeding up. So acceleration is positive and velocity is positive, which means that since they both have the same sign and direction, that means that the object would be speeding up. Okay, so those forces are working in conjunction with one another. And if it happens that acceleration and velocity have opposite signs, you would say that it's slowing down. Okay, last question on this context. When does the particle change direction? Well, assuming that this particle has a continuous path, in order for it to go to the right and then turn around and go left, it actually has to stop momentarily before it comes back. So to find where the particle is changing direction, we just want to find where is the velocity equal to 0. So if I go back to my velocity function, which from earlier we discovered was 2t minus 4, set that equal to 0 and solve for t, so add 4 over, divide by 2. T equals 2 seconds is where it's changing direction. Now if you want to analyze which way is it going, you could actually be a little bit more specific, because we can just kind of do a sign chart. You can think about the direction of this thing. And at t equals 2, we know that the velocity is 0. But we can just quickly analyze what's happening on either side of 2. Before we get to 2, like for t equals 1, for example, I'll pick any number in this interval. We started at 0, so I won't get any far left than that. If I put a number like 1, the velocity, 2 times 1 is 2 minus 4, the velocity is negative. Okay? Which means in that particular interval, we're going from to the left. And from to the right of 2, we could plug into like a number like 3 into this function. 2 times 3 is 6 minus 4.